This video demonstrates Mini Project 5.6, how to use a digital multimeter to verify Ohm's law. What you will need is you'll need your protoboard, your Circuits 1 parts list, a 9-volt battery, a 9-volt battery clip, your digital multimeter, probes, and optionally a pencil and paper. Additionally, it'll help if you want to do extra credit type stuff to also have your 2 AA batteries and your 2 AA battery clip. We're going to set that aside for now. The first step is we need to measure the voltage of our battery. So step number 2 is that we're going to turn the digital multimeter to the DC voltage setting, and we're going to plug in the red probe to the right side, the black to the middle, and we're going to measure the voltage across our 9-volt battery and record this value. So we probe the 9-volt battery, and we get 9.71 volts. So we have V is equal to 9.71 volts. The next thing, from the Circuits 1 parts list, the only parts that you're actually going to need are the 470 ohm resistor. So let's pull one of the two of them out. And we'll also need a 1 kilo ohm resistor. So let's pull that one also out, but set it aside. We can now put aside our circuits part list. Okay, so with the 470 ohms, we're going to attach this into the breadboard. So I'm going to pick a column. I'm going to pick column 10 because I like 10 for some reason. And I'm going to plug one end of the resistor into column 10 on the top half. I've used this 470 ohm resistor quite a lot. Let me pick the other 470 ohm resistor, which is a little bit less bent up. Okay, so we plug this in to column 10, so one end on the top. And the other end on the bottom, column 10. Okay, maybe there's something with this particular hole. It's not going in correctly. Okay, let's pick a different row. Wow, I'm having a lot of trouble with this one. Okay, that's made electrical contact. All right, so now we're ready to measure the resistance of this resistor. So we turn it to the white ohm setting, and we're going to touch the two sides of the resistor. So we touch the left and the right side, and we read 0.460 K, there's a K at the top next to auto, ohms. So this is 0.46 kilo ohms or 460 ohms. So we record the resistance is equal to 460 ohms. Okay, so now we should be able to calculate how much current we expect from it. So using Ohm's law, we're expecting 9.71 volts divided by 460 ohms, or 0.0211 amps. So we're expecting 0.0211 amps, which is equal to 21.1 milliamps. Okay, we are now ready to measure the current flowing through the device. So in order to do this is step 4, we're going to set aside the digital multimeter, and we're going to attach the 9-volt battery to our circuit. So I like to plug in the battery into the circuit first, and then plug the battery into the battery clip. This ensures that we don't accidentally let the legs of the battery clip touch each other and short out. Okay, so I've got on one side and I've plugged it in the other. So I have the red in column 10 at the top, I have the black in column 10 at the bottom. I'm ready to connect the battery to the resistor, and now I should be flowing about 21 milliamps of current. So we have a complete circuit. Now in this configuration, we cannot measure the current. So in order to measure the current and verify Ohm's law, we must break our circuit. So the way that we can break our circuit is we can disconnect the black end of the resistor and plug it into a different column. And so for clarity, I'm going to plug it into column number 15. Now, to measure current, we need to set our digital multimeter on the correct setting. So the first thing to do is that you need to move the probe to the left-hand side. When you're measuring current, the circuit must be open and you're going to insert the digital multimeter in series with the circuit so that you can measure the current that's flowing through the circuit with this low impedance or low resistance device. If I just try to measure across this resistor, all of the current will flow through the multimeter and it'll blow out the fuse in the back. So I need to measure in series by first breaking the circuit. Okay, so because I may not necessarily know the current, I'm going to use the highest current setting. So just in case the current is much higher than I expect, I don't damage the digital multimeter. So I'm going to go on the 10 amp setting. So I'm going to turn all the way to the left, 10 amp setting. Now, I need to be able to probe at these locations. So depending on the parts that you have, the way to probe, we're going to probe left hand or the left side on the resistor. The right side, we need to somehow touch this the metal on the black side. So when it's in the board, you can't really probe it. Like this probe will not fit inside these holes. So what you would have to do is you'd have to pull out this pin and just touch it when it's on the outside. So you just rest it somewhere and then you touch, or maybe you hold it. Wow, this is moving around a lot. Okay, so I touch these two together. And then the other side, I'm touching the resistor. Okay, can't do it with one hand. All right, I touch it here, and I touch the other end of the resistor, and I see 0.02 amps. So that's saying 20 milliamps as I expect. It's slightly off, but it's close. So I've measured 0.020 amps or 20 milliamps. Now that I know that the current that's flowing through this resistor is safe, it's less than 200 milliamps for the multimeter to read, because the multimeter, it says it's 200 milliamp max fused, meaning that if you put more than 200 milliamps on the sensitive setting, it'll blow out the fuse. So now that we know that it's small enough, we can measure on the more sensitive setting and get a more accurate reading. So what we're going to do is we're going to move this to the blue milliamp setting on the left-hand side, DC, and we're going to move the probe back to this side. So on this side, I can measure milliamps on the sensitive setting. Again, if this setting, if I measure the circuit and I connect across the resistor, I'm going to blow out the fuse in the multimeter. So it's important that I've broken my circuit. So what I'm going to do, I'm going to have one side is going to be probing the resistor. The other side is going to be probing the battery. So I'm going to hold this on this side, and I'm going to touch the other side. So I've made a closed circuit, and I get 20.5 milliamps. So that's a little bit more accurate. So on the sensitive setting, I get a closer value. Now, the reason that I don't get exactly the same value as I expect is because the battery has a little bit of internal resistance. And so the current that I measure is slightly different. Okay, so at this point, I want to point out, so we did not always include this, but if you have what are known as bird pins, which the STEM clubs will have, you can use these to measure current much more easily than holding the things that I did. So what I can do is I can use, so these are electrically isolating, I can plug this into column 10 and 11. And what that does is it basically allows me to have a place where I can connect my probes onto the proto board without having to hold the wire in place. Okay, so column 10 and 11. Okay, press that in. And what I'm going to do with the black probe is now I'm going to connect it to column 11. So my circuit is open because I have current that wants to flow in through the resistor, come to the bottom of column 10, but there's no connection between column 10 and column 11, and then the current would flow back. So the way that I make the connection is by measuring the current in series. So now instead of holding those things in the air, I can just touch these two Berg pins, and I can see that I get 20.5 milliamps. Okay, so that's how you measure current. So the next step that we're going to do, we're going to measure the 470 ohm resistor. So rather than redo all the measurements in order, what I'm going to do is, since we're already set up for current, I'm going to measure the current flowing through this resistor. Now, this circuit is already broken, so I have a safe configuration where I don't have current flowing and I'm trying to take components out. In general, you don't want to take components out of a circuit. You want to turn off the power supply by unplugging the battery. But my circuit is already open, so I can take components out. So I'm going to take out this 470 ohm resistor, set it aside, and I'm going to put in the 1 kilo ohm resistor in the same columns. So go ahead and do that. Okay, so I have my resistor in place, and now I'm ready to measure current again. So I've increased the resistance. To do this measurement, for safety reasons, I should switch back to the 10 amp setting. I should move my probe over and measure it to make sure it's less than 200 milliamps. So I measure in this configuration, and I get 0.009 amps. So the measured, so this resistor we don't know yet, it's about a kilo ohm. The measured is 0.009 amps. Okay, so now I'm going to measure on the more sensitive setting, because 0.009, I only have 1 digit of precision. I want to get this more accurate to be able to check. So now I'm going to measure on the DC milliamp in blue setting. And so I measure, oops, I forgot. I have to move the probe back over to the other side. So back over on this side, I'm in the DC milliamp setting. And I measure and I get 9.73 milliamps. So I record my measured is 9.73 milliamps. Okay, the last step is for this other resistance, I have to measure the resistor. So I'm going to disconnect my battery from the circuit. So this is out of the way. I'm going to take the battery out of the battery clip and set the clip aside because the clip can sometimes short. So I'm going to set that aside. I'm going to go back to the ohm setting and measure the resistance of this resistor. So I measure the resistance by touching the two sides, and I get 0.978 kilo ohms, so 978 ohms. So I still have 9.71 volts. I have 978 ohms, so 9.71 divided by 978 is equal to 0.00993. So what this is saying is that I'm expecting 9.93 milliamps, and I got 9.73. So you can see this is a little bit closer, and the reason it's a little bit closer is because the resistance is much higher, and so the effect of the resistance inside the battery is smaller. So if you want to explore further, what you can do is you can switch now to the 2AA settings, and you can plug in the 2AA batteries and measure the current that's flowing through the circuit, and then also measure the voltage across the battery, and also check with the other resistor to verify Ohm's law. So what we've seen from this activity is that Ohm's law is validated. The current is equal to the voltage divided by the resistance, and we verified this by using our digital multimeter.